tylko wycinasz, nie?
No. Now we need the ball like snowball in Poland or donut in Poland. Teraz musimy każdą kuleczkę taką ukręcić. And now we need to roll them, okay? So grab a rolling pin, but don't do too thin. Okay? It's 3-4 mm. Słuchajcie, teraz musimy rozwałkować, więc niech każdy weźmie wgrabywały. Trzeba rozwałkować, ale nie za cienko i nie za grubo.
On totalnie tak cały posmarować,
cały posmarować. I to
żeby
bardzo
się do foremki nie
uspokaja.
przyczepiło, wiesz?
No ale wszystko co dobre się kończy, nie? No. Tak to jest. A dobrze, że i złe. O, excellent. No spokojnie.
Mogę
Trudno
pokolorować.
znaleźć takie puder.
Chwila.
Mąki też tyle rodzaju, że patrzę kto.
Żałują ci, co nie przyszli, nie?
Tak, no.
to the Polish pavilion. Don't panic, we're from Poland. All right. Yeah. Right. There will not be a new beginning. It's only here and now, people. There will not be a new beginning. Yeah. It's only here and now. We are here in a given time, in a given moment, in time and space. Yeah. Use it well, people. Use it well, people. Use it well, people. Use it well, people. People. Use it well.
Dzień dobry.
Dobry.
Co tu dzisiaj o kosmosie?
Bo to jest... Dzień dobry. Hello.
In the morning it's cloudy, very
Guten Morgen. Guten Tag. Schneller, schneller. Wiemy nie tu więcej. Szybciej, faster, faster. Schneller, schneller.
Actually, you can find the snow. Because they're hot.
How people will look in the future when we live in the space. That will not try to look at the humans. Aggressive, more grown, more future.
So that's why you can do the work of correspondence.
Planetary system, besides the solar system.
Wiesz, że to jest światłem?
Będę podawał te przykłady zaraz sygnału, wtedy nawidujesz.
Taken today by Solar Dynamic Observatory sent by NASA a few years ago, but these images are sent to our planet even every few minutes. So it's live broadcast. As you see, sun was absolutely fantastic and very active. You can see 3 active regions. You know, from Earth we see active regions, but if we go closer to the sun, we can see prominences like here. This is a fantastic movie, also recorded by Solar Dynamic Observatory. This is not today activity. This is the best activity recorded in the last 5 years. So this is the best of the best of solar activity. We are living now in a very interesting moment because solar activity starts in creates. Probably you know that solar activity, we have very famous period, 11 years. During this 11 years, we have minimum and solar maximum. And now we are starting to go to solar maximum. But there is something strange because our sun starts to go to the maximum much faster than we expected. So we don't know what will happen. It's too complicated physical system, our sun, to predict with 100% probability what will happen. And here you can see how it works. The red line is predicted, but the scattered line, these are real observations. Last weeks, last months, it looks like it goes faster. This is a bad information for us because it means that minimum comes. Other particles from outside of our solar system came, and also you know, it's also not good for our life here. Of course, we are protected. The protection on Earth is geomagnetic field. We cannot see it, but we know that there is something. Of tons of solar matter goes to the sky, to the solar system space, and then it hits Earth. When it hits Earth, we can expect a situation like here. This image was taken tonight, last night, in Tromsø, in Norway. Parts of the sun just enter Earth's atmosphere, especially magnetosphere, and start our Earth's atmosphere to send light. This is aurora, northern lights, southern lights, as you wish, and other names. And here you can see how the Earth is hit by today by solar particles. We can say that we are safe here in Dubai because we are far from the polar circle, north or south. but people living in close to the polar circles can cause problems with power supply because there can be some damages. As you see, everything is moved to the North America continent because there's shift between magnetic axis and Earth axis. So in Europe, in Dubai also, we are much better. We have better situation. This shows where are the places which are, you know, some kind of geysers of activity. So this black part in the center, it's exactly pointed to the Earth, and everything which goes through this coronal hole, we call it coronal hole in sun atmosphere, everything from that part goes to Earth. So we can expect next few days auroras. Of course, even in Dubai it's possible, but we need to have strong emission from the sun. Okay, first example, geomagnetic hiss. And another example, auroral horus. Very strange signals, but auroral signal, it's a whistler. We have also solar burst. I speeded 43,000 times, so it means 1 second. In this recording, it's 48 hours. And the last solar signal is electrons. So it's a small part of the solar mass which try to escape from the sun, but no gravitation, but the magnetic field just decelerate them. When it decelerates, sends a radio signal. We cannot see it, but we can hear it. Solar electrons burst. And now I would like to tell you about something which is also connected to astronomy and radio signals, and it's a part inside the building, Polish building. It's a part of exhibition, pulsar. First astronomer who discovered extrasolar planets, it's Alexander Wolszczan from Poland, from Kujawsko-Pomorskiego. And I'm going to give you a few audio examples how the pulsar sounds. First is a recording coming from Toruń radio telescope. I show you this radio telescope. This is our device, the biggest in Poland, the biggest in Middle Europe, Middle West Europe. And of course, this sound comes from our telescope. Of Vela pulsar, it's 12 rotations per second, 12 hertz. these pulsars are extremely fast. They can rotate few hundred times per second. And of course, the signal also is very fast. You cannot hear one pulse, it's a tone. So it's a one mixed signal. Now I'm going to give you the last example of pulsar sound, solar cluster. Millisecond pulsars, few hundred pulses per second. We can start with the sunset. We can on some constellations, and this is the current situation. We can see Sirius, very bright star in Canis Minor, but the best constellations we can observe at the moment is Orion. Probably you heard about Orion. Here is the constellation. You can see 5 very bright stars here. 1, 2, 3, 4, 5. And in the middle, it's an Orion belt. 3 stars, Mintaka, Anilam, and Alnitak. This is, of course, Arabian names. And you know, if you became an astronomer or amateur of astronomy, you could know that probably all stars are names. Their names comes from Latin or Arabian language. You can imagine if you see something like that, 5 stars and the Orion belt inside, you can watch a little bit, not directly below the Orion belt, but a little bit in this direction, and in the angle of your eye you can see very thin cloud. This is M42, probably one of the famous nebula. This is the place where new stars are born all the time. So we can observe this nebula, fantastic. This fantastic shapes comes from the dust and gas. This is Taurus, and the brightest star in Taurus is Aldebaran. Aldebaran is very important because even using a naked eye, no telescopes, no binoculars, you can see that this star is red. So if you don't believe me, you can try to find Aldebaran. You can see that this is more red than blue. If you compare Aldebaran to Sirius, which I mentioned earlier, Sirius is blue. So, questions, which one is hotter? For tomorrow. Tomorrow we are going to observe moon. Today is very close to the horizon line. It's about, at the moment, 11 degrees above the horizon. But we can also have a Jupiter, fantastic planet, fantastic because the biggest in solar system. Using a small telescope, all telescopes here can show you this fantastic structure in the Jupiter atmosphere. Of course, in Jupiter there is no solid surface. It's only, gas giant. Unknown artifact in the atmosphere of Jupiter is great red spot. We don't know what is this. Probably this is hurricane, but this hurricane is on since few hundred years. It's very thin, few maybe 1.5 days after the closest approach to the sun, and every day we will bigger, and in 1 week we will have first quarter, and we can observe a half of the moon. But if we convert directly, we will hear nothing because the changes in the signal are too slow. So we speed up it 10,000 times, and then we can hear a singing comet. First example. Jupiter bow shock. Jupiter magnetosphere.